Right, so last week I had a fairly unsatisfying video where I messed about with doing pi in Monte Carlo in MATLAB and trying to parallelize that and got a bit of a speed up, but not very much. And then I went home because it was a strike the next day and I was not going to be in. It was fairly unsatisfying and I was fairly grumpy about it. And so I thought over the weekend I would write something nice related that I could upload as a short video now. And so what I decided to do was do a graphical version of that code. So we'll show you how the code is plot. I'll show you the points as they're calculated and plotted. I developed this at home on a home machine, so I did it in Octave, which is a kind of open source version of MATLAB that's a bit odd, even by MATLAB standards. It's a lot slower, and the language designers have decided to do something a bit odd, which is they've kind of created like a superset of the MATLAB language. So if you write stuff in Octave, you then have to spend a little bit of time porting it back. A good example is the dot syntax for applying operators to matrices and vectors. You can do dot plus and dot minus in Octave, which you can't do in MATLAB. I think it just works out automatically. And Octave really likes to end functions with like end function and end4s with end4 rather than just end, and those are not valid MATLAB syntax. Okay, so we had this code last week, right, which was fairly short. We parallelized it with par4. And I wrote the new codes so that they do some visualization. Let me just minimize that. It's in GitHub. I've got a little repository here for doing like weird things with pi, which is not linked to the main one. Right. So there's two versions. There's a slow version which plots each plot as it goes. I thought there might be a quicker way to do this. So what it does is it uses scatter to draw each of the points, but it turns out that's the valid way of plotting a single plot point in MATLAB, and it's not the quickest. So you could really run version 1 with very small numbers of n, unless you want to go completely insane. But it does show each plot as you go, and I've got a version which does all the points in one go, which is obviously massively faster. So let's do the first one first. So 500 is enough to be annoying, so I'll pause the video and then record the next bit when it finishes, but let's set that off. So as you can see, it draws the line, right, with the radius of 1 around the origin, and then it plots each point. If the point is inside the line, it plots it in red. If it's outside, it plots it in blue. Right, it's finished. It took 132 seconds, which is, not compelling YouTube viewing. And the answer it gets is pretty inaccurate, but we know this because the Monte Carlo method for estimating pi is horrendous, right? What we can do though is, if we clear the figure, we can rerun it with the version 2 of the code, and let's say 500,000 points, and it does not draw. Why did it not draw? Oh, there we go. And it draws it. You see, it's almost completely filled it in, right? I guess there was a bit of lag there because it's so many points. And then we still get a terrible version of pi, but it's a bit closer. One of the anti-features, or possibly features, of MATLAB is that when you start up, its random number generator is always in exactly the same state, which means you'll get exactly the same points every time you run the code the first time. That's annoying. You can see the random number generator with specific commands, so why don't we go ahead and do this? So let's do that then. You control the RG with the random number generator with the RG command. And I believe if we do this, it should set it to the initial configuration. Yeah, so what it's done there is it set the C to 0, and it set the Messiaen twister, or whatever, however you pronounce that, as the generator. It has some other ones you can do, but you can set the seed. So, I mean, to prove this is happening, right, we can do x equals rand, get point at 7, and we reset it, and do x equals rand again, get the same number, right? We can set it with like some random number, and then if we do it, x will be a different value, right? Let's think, what else can we do to show this a little bit? There's another setting which sets it to be the right value. So normally when you run code, most programming languages, they do something where they set it based on the current time. And the command for that is shuffle. So you do another thing I don't like that is a MATLAB pattern, and it's in the language a lot, is this thing where you call a function with a string that tells it what to do. That's not nice. And this should give us a different value each time, right? Because that's set on the seed based on the current time. Okay, so what do we want to do to show that off? Right, let's run the graphical, the fast one actually with a small number of iterations, and set each of those so we can see that we're getting different points now. So if we do x equal, set the RNG to default, and then we do MCP2, but do like 50. Like we've got a little pattern here, right? You sort of keep an eye on where those spots are. If we reset it to default, we should get the same pattern. We get the same pattern. If we set it to shuffle, we should get a different pattern. Look at that, the points changed. So one of the things, if you're doing anything in MATLAB that involves random number generators, or actually any language, you should read the documentation, because one of the anti-patterns that I was helping a user out with last week is that in order to guarantee they got the same answer out of their code, they had saved a massive, great big MATLAB table of pre-generated random numbers, and actually they could have just controlled the seed and done it live and not had a big I/O read in at the start of the program. So that's all for today, and good luck using our machines.